Welcome back to The Explainer. Today, we're initiating a high-stakes briefing on a biological threat that operates completely under the radar. We're tracking a zoonotic pathogen that doesn't need an elaborate delivery system or a targeted strike to infiltrate human biology. It uses the very air we breathe. We're talking about the Hantavirus.
I want you to pause for a second and just think about this. What if the dust you breathe could kill you? Seriously, we are talking about some sci-fi movie concept here. We're looking at a terrifying, entirely real scenario where an invisible airborne pathogen can turn a routine chore, like sweeping out a closed-up cabin, into a lethal encounter.
To really grasp the scale of this enemy, just look at this number, 150,000. That is the estimated number of hantavirus infections happening globally every single year. So while it might seem like a rare, isolated phenomenon, this virus is quietly maintaining a massive footprint across multiple continents, constantly spilling over from wild reservoirs directly into human populations.
And here's where the reality gets truly grim. 50%. In the Americas, an infection can lead to what's called hantavirus cardiopulmonary syndrome. This manifestation of the disease carries a shocking case fatality rate of up to 50%. You heard that right. Once it takes hold, it's essentially a coin toss for survival.
Section 1. The pathogen threat. Profiling the hantavirus.
Take a look at the sheer, terrifying efficiency of its design. The virion has this spherical, kind of pleomorphic shape, measuring roughly 70 to 350 nanometers. But its primary armor, that outer lipid envelope, it's actually a protective bilayer that the virus snatches directly from the host cell's membrane as it replicates. It literally cloaks itself in our own cellular material to evade detection.
And protruding right out of that stolen envelope are its primary weapons, the N and G surface glycoproteins. These spike proteins are arranged in a highly ordered, symmetrical, grid-like lattice pattern. The N forms the stalk, and the G forms the head. Working together, they function exactly like microscopic lockpicks, allowing the virus to seamlessly bind to and completely infiltrate human endothelial cells. It is frankly a biological masterpiece of forced entry. Section 2. Vectors and infiltration, breaching our defenses.
So, how does it get in? Well, the hantavirus relies primarily on rodents, mice, rats, voles, who carry the virus completely asymptomatically. They act as Trojan horses, shedding the virus continuously in their urine, droppings, and saliva. The primary breach of our defenses actually happens through inhalation. If you sweep a dusty, infested shed, those viral particles are aerosolized into the air. You breathe them in, and the infiltration begins. Now, you can also contract it by touching a contaminated surface and then touching your face, or through a rodent bite. And while human-to-human transmission is incredibly rare, it actually has been documented in South America with the Andes virus strain, passing between close, prolonged contacts.
And whatever you do not underestimate the resilience of this pathogen. Outside of a host, the hantavirus is a lurking, unseen landmine. It can survive up to 15 days in a normal temperate environment. And if temperatures drop near freezing, it can last for more than 18 days. It just waits, patiently, in the dust, for a new host to arrive.
Section 3. Clinical strike, the physiological impact.
Once inhaled, a silent ticking clock begins. The incubation period can drag on anywhere from 1 to 8 weeks. During this time, the virus is quietly, systematically multiplying. Then the initial phase hits with these deceptive, really nonspecific symptoms: fever, extreme fatigue, and intense muscle aches, usually in the thighs and back. It just feels like the flu. But then, the critical phase strikes with terrifying speed. Patients experience a sudden, catastrophic onset of severe respiratory distress, plummeting blood pressure, or acute kidney injury. The virus directly attacks the vascular system, basically causing your blood vessels to leak. Now, the virus actually manifests differently depending on geography and the specific viral strain. In the Americas, we see Hantavirus cardiopulmonary syndrome, or HCPS, which primarily targets the lungs and heart, causing the lungs to rapidly fill with fluid. Over in Europe and Asia, the virus causes hemorrhagic fever with renal syndrome, or HFRS, which aggressively targets the kidneys and blood vessels. Notice the stark contrast in those fatality rates here. HCPS is incredibly lethal, killing 30 to 60% of those infected. Section 4. The missing cure, a terrifying vulnerability. I really want this harsh reality to sink in for a second.
Despite decades of intense medical research, there is absolutely no FDA-approved antiviral drug or vaccine available for hantavirus. None. Once you're infected, modern medicine has no magic bullet to kill the virus. You are entirely reliant on your own immune system to win a brutal, exhausting war of attrition. Because we lack a cure, the medical response relies entirely on desperate, purely supportive measures inside an intensive care unit. For respiratory failure, patients require mechanical ventilation. In extreme cases, they need ECMO. That's a machine that literally pumps and oxygenates your blood outside the body because your heart and lungs have just failed. For HFRS, patients might require severe dialysis. The goal isn't to cure you, it's simply to keep the human machine running, just long enough for the body to clear the pathogen on its own.
Section 5. Containment. Urgent prevention strategies.
Since we can't cure it, we have to prevent it. Think of these steps as a fast-paced survival protocol. Step 1. Seal up. You must harden your perimeter, block literally any hole larger than 1/4 inch to deny rodents entry. Step 2. Trap up. Actively deploy traps in any sector showing even a hint of infestation. And step 3. Clean up. Eliminate any food sources and nesting materials that might attract the vector to your living space in the first place. The CDC's primary defense strategy for homes and workplaces comes down to exactly what we're looking at here. Seal up, trap up, clean up. I know it sounds simple, almost too simple, but flawlessly executing these 3 directives is literally your front line of defense against a lethal outbreak in your own home or workspace. But listen, if you do encounter a breach, if you find rodent droppings, you absolutely must follow strict decontamination procedures. Never dry sweep or vacuum. Remember what we said earlier? Aerosolizing the dust weaponizes the virus. Instead, you must pre-dampen the entire contaminated area with a strong disinfectant like bleach or 70% ethanol. Let it soak. You have to keep it visibly wet so the lipid envelope of the virus is totally destroyed before you even touch it. And it goes without saying, always use disposable gloves. Now, stepping back to a macro level, global health organizations like the WHO are fighting this through what's called the One Health approach. This global strategy acknowledges that we can't just look at human medicine in a vacuum. We have to constantly monitor the intersection of human activity, rodent population dynamics, and environmental shifts. Because outbreaks surge when climate factors cause rodent populations to explode and spill over into human habitats. It's essentially a continuous global intelligence gathering operation.
We've covered the chilling structure of the pathogen, its devastating physiological strike, and the terrifying lack of a medical cure. The threat is real, it's global, and it is hiding in the dust. So take a look at the spaces you inhabit. The virus is invisible, and the wild reservoirs are already out there. Are the spaces around you truly secure? Think about that the next time you open up a dusty, forgotten room. Stay vigilant, stay informed, and I'll see you in the next explainer.